Is hexagonal architecture introducing too many abstractions and too many redirections? Let's discuss this. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from a secret location, not from the Mozaic Works studios. And today what I'd like to discuss is a LinkedIn post by Javier Araujo, I hope that's how you read his name, who is complaining a little bit about hexagonal architecture. And since I am very interested in this topic, I think that hexagonal architecture is one pretty good idea. Let's see what he has to say. It's useful to listen to criticism. Remember that every type of architecture has trade-offs, and we want to understand these trade-offs. In my current role, we've extensively used hexagonal architecture. The goal was clear and made sense in theory. Abstract all external interactions to make future replacements easier. Now, from here, I would argue that this is not necessarily the goal of hexagonal architecture. Sure, one of the effects that you obtain by following hexagonal architecture is that you can isolate yourself from the external systems. But I think a much more important role is that you are able to define your domain in a clean way. And that's where I think hexagonal architecture shines. By the way, if you need an introduction into hexagonal architecture, we had a whole video about this. So feel free to pause here, watch that video, and then come back. But briefly, hexagonal architecture is about ports and adapters. That's maybe a better name. And what it means is that for every interaction with the outside world, you define a port inside your domain. So basically you have your domain, you have a port, and then you define things that plug into that port, and sometimes they need to be adapted, and that's where you need adapters. The reason why it's called hexagonal is because initially it was displayed as a hexagon, but the hexagon actually has no meaning. You never have exactly 6 ports, but it was a nice way of showing it in the beginning. So where this works is that you can indeed isolate yourself from external systems, but I believe even more than that, the ability to have your core domain clearly separated, and the ability, which I believe will make even more sense, the ability to have micro tools that can plug into your domain, as for example command line tools or processes, batch processes, or other types of services. I believe this is what makes this even more interesting. But yeah, indeed, it's possible that if the problem is too simple, you don't actually need hexagonal architecture. So, but let's see what he has to say. But after applying this approach across multiple services over the past 4 years, I've come to some hard-earned conclusions. The boilerplate required by hexagonal architecture introduces heavy indirection, making code navigation significantly harder. I'm thinking if that is correct. That is correct if you don't follow the proper names. And in all fairness, the book on hexagonal architecture is still not finished. And it's only been quite recently published. So it's very possible that some people don't know yet how to apply hexagonal architecture and how to properly name things. If you properly name things, then navigability becomes easier because you can just search for port something or adapter something, and that works. Adding new features often requires more code than necessary just to follow the architecture's rules. Well, honestly, this is the point for every architecture. The goal of architecture is not necessarily to improve, reduce the amount of code that you need to write per feature. That would be mostly a usability rule, a usability concern. And by usability, I mean a usable software design concern. And that is a valid concern. But every architecture will require you to write more code than necessary just to follow the architecture's rules. And the reason for that is because you need to fit into the constraints and into the architectural concerns. That's just how it works. I mean, if you do model view controller, same thing. You need to put things into model, into view, into controller. You could just write all of it into a single file. Why not do that? Well, because it creates other types of problem, changeability, so on. So, while this is a valid concern, it depends how much more code you need to add. Not once have I seen an actual job situation where these abstractions paid off, but we did spend a lot of time creating and maintaining them. Well, let me give you one thing that will always be useful, and that is writing tests. If you have all your core behavior completely separate from the outside world through ports and adapters, then you can fully test your core behavior in memory using very fast unit tests. Isn't this something that's valuable for your project? Well, if the project is quite small or not very complicated, or if it doesn't quite fit the domain, the problem domain where hexagonal architecture works, which is very possible, then yes, it won't be as valuable as other things. But if you, in most cases, I think the ability to write tests and very quickly test everything, that's a very good thing to have. But I get the point that often you don't need to change the external thing. So once you decide on a database, you don't change the database. Once you decide on a payment gateway, you don't change it. Or these are very rare events. So then it might seem extra work just to maintain this. On the other hand, if your system needs to work on multiple operating systems, if it's more of a platform thing, or if you treat it more like a platform thing upon which you can write tools, then it's obviously something very useful. Even in the few cases where abstraction could help, it didn't. Why? Because abstractions leak. For example, switching from a relational to a non-relational database changes access patterns so drastically that implementing the same interface isn't enough. That's true up to a point, yes. I can see that. Although one option here would be to think in terms of queries and commands instead of thinking in terms of tables or entities. And maybe that's one of the problems. There's a trap in hexagonal architecture and in domain-driven design in general. Now, hexagonal architecture and domain-driven design intersect. They are not the same thing. You can do hexagonal architecture without domain-driven design and obviously the other way around. But they have the same problem in which it's very tempting to create entities that link directly to database table, and that means coupling between your code and the database. So if you do that, that's not domain-driven design, and that is definitely not hexagonal architecture. Instead, as I said, one option would be to have queries and commands. And these are your abstractions that you use. And then if you change the database engine, you change the queries and commands. However, this has limitations as well, because performance is different for relational versus non-relational databases, and you might need to adjust some things just in order to maintain performance or scalability. And yes, absolutely. So none of this flexibility that any architecture offers is for free and infinite. You have limitations always. All these made me question this instituted approach. Do we really need these abstractions up front? Wouldn't it be better to add them only when, if ever, we actually need them? Yeah, that is an option, but honestly, I think if you're developing using test-driven development, you will need them anyway. And if you want to write fast tests and so on, so you'll need them anyway. Because of that, and if it's not these particular abstractions, ports and adapters, you'll need other abstractions. So, yeah. Of course, there's no silver bullet. There are situations where abstraction can make sense, but far too often we adopt patterns like hexagonal architecture because they look good on paper, not because they solve a real problem. And in doing so, we overcomplicate our systems unnecessarily. Yeah, that is correct. Whenever you pick an architecture, you should always start from the non-functional requirements. And by the way, if you want examples of this, we have a set of performed architectural katas where I can show you how I make decisions, architectural decisions. One of them was actually a live stream. So if you want to see a free preview, you can go and watch the live stream and see a process of architecting that takes into account the non-functional requirements. However, this post is not about hexagonal architecture specifically, but rather about how easily we over-engineer in the name of good design. Curious to hear your thoughts. Have you faced something similar in your work? And there's a picture that's needed to ensure it's future-proof. Too much complexity and too much complexity. Yeah, generally speaking, it's better whenever you can to do these things incrementally, to allow yourself options. And the reason is that you don't know the future. Even if your product people tell you that there is a clear path forward and you know exactly what will happen and we know exactly what we'll need to do and so on. Most of the time, that is not correct. Some things will change. Okay? And so you need to be able to adapt. And if you allow yourself these options, it's easier to adapt. With this being said, it depends a lot on the context. Are we talking about one team that is working pretty closely together? It's a pretty small team. Are we talking 10 teams that are co-located at least in the same geographical area? Or are we talking 50 teams and all of them are around the world? Because things change fundamentally depending on this. Remember that architecture is about socio-technical systems. You cannot do architecture just technically. You need to take into account all the social and technical aspects. Let's look a bit at the comments. I think I saw a few comments. It's good to have patterns, styles, and methodologies at hand, but in software engineering, you need to understand when to apply what code. There is never a one-size-fits-all approach. Yeah. You ain't gonna need it. The eternal fight between keys and scalability. Yeah. The boilerplate required by hexagonal architecture introduces heavy indirection, making code navigation significantly harder. This definitely hit home, and there are enough people talking about the cons of the interface segregation principle. And it's a consistent issue on most code bases that needs to be addressed. Glad to see I'm not the only one feeling that pain. Yeah, interface segregation is not a perfect principle, and I think there are limits, but maybe that's a good topic for another video. That's it from me for now. What do you think about this? Have you found any issues with hexagonal architecture? Let us know in the comments. We love comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.